Today we are going to find the quotient and the domain of the quotient of the functions f of x equals the square root of x and g of x equals the square root of 4 minus x squared. The quotient of f and g is f over g of x equals f of x over g of x. So we can write the square root of x over the square root of 4 minus x squared. Let's do the quotient of g and f too for the sake of practice. So g over f of x equals g of x over f of x, which is the square root of 4 minus x squared over the square root of x. If we want real numbers as solutions for the square root, we have to restrict the domain from 0 to infinity. So the domain of f is going to be 0, infinity. What about the domain of g? Ask yourself, when is the square root of 4 minus x squared 0? The square root of 4 minus x squared is 0 for x equals 2 and for x equals negative 2. So the domain is going to be from negative 2 to 2. When we plug in a number less than negative 2 or greater than 2, we are going to get a negative number under the square root, which we don't want. Now, how can we find the domain of the quotient of f and g and of the quotient of g and f? Let's visualize the domains of f and g on the number line for better understanding. The domain of f goes from 0 to infinity, and the domain of g goes from negative 2 to 2. So we can say the domain of f of x over g of x goes from 0 to 2. Note that 0 is included, but 2 is not included. Why is the 2 not included? I really encourage you to pause the video and find the answer to this question. The 2 is not included because when we allow the 2 to be in the domain, we would get 4 minus 4. Which is 0, and the square root of 0 is 0. So we would get a 0 in the denominator, which is not defined. Therefore, we have to exclude the 2 from the domain. What about the domain of g of x over f of x? The domain of this quotient goes also from 0 to 2. But the 0 is not included. The 0 is not included because the square root of 0 is 0. And 0 is not defined in the denominator. Recall that any restrictions on the domains of two functions must be considered when forming the sum, difference, product, or quotient of two functions. If you like my videos, like, share and subscribe. Thanks for watching and happy learning, everyone.